Okay, hello. This is our first lesson. We're going to start the unit with series and sequences, and the first unit is sequences. So the aim is sequences. And I'm going to get a new black pen because this one is dry. So the question is, we're going to be talking about patterns, terms, and generating sequences. So what is it? Let's define sequence. So I want you to copy these notes down into your notebook, and I want you to pretend that I'm standing right in front of you. This is on. Yeah, and slow the video down. If you have to, speed it up, but it's fine. A sequence is a list of ordered elements. Now in this class, we're talking about numbers. You know, Monday, Tuesday, Wednesday, Thursday, Friday, that's a sequence. But you know, the kids in the class, that's a sequence. But in this class, we're talking about numbers. So the elements are numbers. And each number is called a term. A term. So if I give you the sequence 3, 7, 11, and 15, how would we describe 3? We'd say 3 is the first term, and we would say that 7 is the second term. Okay. So, but the definition talks about order, right? Order elements. So the question is, where's the order here? Where's the order in 3, 7, 11, 15? Where is the order? Right, that's the question. What is the order? And you say, oh, it goes up by 4. Increases by 4, positive 4 each time. Well, we don't need the positive, that's redundant. It increases by 4. So I could say, you know, you have the first, the second, the third, the fourth. I could say, what is the 5th term? And you would say, anyone? Oh, yeah, 15 plus 4, it's 19. You know, what's the 6th term? You say, okay, just go up another 4. So 19 plus 4 is 23. Good. And then I would like you to figure these out. So I'm going to give you some sequences, and I want you to write down the next 2 terms. So the first sequence is 5, 10, 15, 20. Find the next 2 terms. 2, 4, 8, 16, find the next 2 terms. 30, 30, 27, 24, find the next 2 terms. I want you, how about 256, 128, 64, and 32, find the next 2 terms. And then I want, how about this one? 1, 4, 9, 16, 25. Find the next 2 terms. So pause the video, or freeze the video, write these down, figure it out, and then we'll come back in a second. Okay, we're back. So the question is, what are the first thing I want to know is, what is the order here? What's the order? So let's use a different color. Let's use blue, right? So what's the order in the first sequence? You said, oh, is plus 5. So 20, 25, 30. What about the next one? What was the order in the second sequence? You would say times 2. It multiplied by 2 each time. In this class, we're going to be studying adding or subtracting, multiplying or dividing. There's other types of sequences we'll see, but we're not concerned with that in this class. So next one's 32, 64. What about the third sequence? Oh, you see it's -3. It's decreasing by 3 each time. Okay, so we continue the sequence. 21, 18. What's going to cut that out of the video? We're going to cut that out. Okay, so what do you think for the fourth sequence? Okay, so you're not really sure. You think it's being divided by a half. Now, in the previous examples, you said, you know what? We said, well, you think it's going down by 2. So maybe you'll do like 128 divided by 256. You get a half. Okay, 64 divided by 128. That's also a half. 32 divided by 64 is also a half. So maybe you keep like multiplying by a half, or multiplying by a half, or dividing by 2. It's the same thing. So you maybe you divide by 2. 16 and 8. And then what's going on here is this order? You might say, well, there's no order, go from 1 to 4, I add 3, 5, 7, that might be the order. You might say, well, some of you might say this is +3, this is +5, this is +7, this is +9, so the next one is +11, and the next one is +13, 49. Anyone notice anything else? Another type of order? And then you might say, you know what, I do recognize order. This is 1 squared, this is 2 squared, that's 3 squared, 4 squared, 5 squared, then this would be 6 squared, whoops, and this would be 7 squared. So as long as it has order, we have a sequence. Okay, let's move on. We want to talk about the general terms of a sequence. So we're going to use U of 1. Sorry, wrong pen. We're going to use U of 1 to represent the first term. Okay? We're going to use U(2) to represent the second term. We're going to use the notation U of n to represent the nth term. And so when I ask you, what do you think comes after the U of n term? What comes after the U of n term? Any suggestions? Well, the answer is U of n plus 1. If the term is U6, the next term is U7, U6 plus 1, that's it. Okay, well, let's talk about these formulas, these sequences, and we want to start to use this notation to represent those sequences. So the first type of sequence is a recursive formula. And the recursive formula is just a fancy way of showing you how to get to the next term. So let's say, is a fancy way of showing you how to get to the next term. So what was going on in the first sequence? We saw that you added 5 to get to the next term. To get from un to u of n plus 1, you add 5. So first example, u of n plus 1 is equal to the u of n plus 5. If the red marker works already, or the green works. So right here, yeah, u of n plus 1 equals u of n plus 5. That's it. It's just the change. What's going on in the second example? What's going on in the second example? Well, you said, Mr. Adler, we're multiplying by 2 each time. So how do we get to the next term? You simply multiply the previous term. That's it. The third example, how do we get to the next term? We subtract 3. U of n plus 1 equals the u of n minus 3. And then the last term, to get to the next term, we simply multiply by a half. We generally don't write like division symbol anymore. So instead of dividing, we're not going to be dividing by 2. We're going to be multiplying by a half. We're just getting fancy. We're getting fancy. So this is a recursive formula. It simply is, how do I get to the next term? Now, the next thing is, the next type of formula is called the explicit formula. Now, why, let's see, explicit formula. So the question is, why do I need another formula? Because if we look at that first example, like 5, 10, 15, 20, and I ask a student in the class, what's the 5th or the 6th term? You'd say, okay, Mr. That's no big deal. Just add 5 on, add 5 more, 25. Add another 5, to get to 30. But what if I asked you, u of 79, 78? Well, you don't want to add 78 times. So, or how do you 70? You do not want to add 74 more times. You need a faster method. I'm going to get right to the 78th term. So the explicit formula takes me. So what's my definition? Explicit formula. It basically tells you how to get directly to the nth term. And that's much more convenient for us because, once again, that's great that I can keep adding 5s, but I'm not adding 5s 78 times. I might ask you u of 312. You're not adding 5 312 times. So the question is, what does an explicit formula look like? So it would look something like this. An example is u of n equals 5n plus 3. So now I can say to you, what's the first, find the first term. And you'd say, okay, no big deal. U of 1 is equal to 5 times 1 plus 3, or 8. I could say, well, I could ask you for the second term. And you say, once again, no big deal. The second term is 5 times 2 plus 3, which is 13. I could ask for the third term. You say, hey, Mr. Adler, no big deal. 5 times 3 plus 3 is, 18? You might say, oh, you know what, look, I see plus 5, plus 5. Now I can say, find the 10th term. Well, you don't have to, you see what's going on here. We're starting at 3. This should remind you of the y-intercept and going up by 5. That's the slope. We're talking about numbers and stuff. You might say, okay, you know what? 5, 5, 5, 5, 5. Nah. We have the formula. Stick in the 10. So u of 10 is 5 times 10 plus 3, 53. Now I can ask you, what's u of 72? What's the 72nd term? U of 72 is 5 times 72 plus 3. Well, you know what? I said we can use the calculator in this class. Where's my phone? Oh, right there. Hey Siri. Well, it's not gonna. You can use your calculator. Use your calculator. So 5 times 72 is what is it? 363. In the notes, for the homework, I'm going to ask you to do some problems. You might see the formula in brackets, like they might write it as 4n plus 3. This is the explicit formula. And so they might say, generate the first 4 terms of the sequence, and you would simply say, okay, the first term is 4 times 1 plus 3 is 7. The second term is 4 times 2 times 3, 11. Excuse me. The third term is 4 times 3 plus 3, 15. And the fourth term is 4 times 4 plus 3, or 19. So, I've uploaded a book to the internet. You're going to do, for homework, you're going to do everything in 5A, 5B, and you can skip 2B. Thank you.